The law of Mendeleev and chemical periodicity. By 1860, nearly 70 elements had been isolated and studied. As elements were being discovered and their properties are being examined, it became necessary to organize them in some useful way that would help to make sense of all. One of the greatest advancement towards this goal was made in mid 1800 by a Russian chemist Dmitry Mendeleev. He made flashcards of the known elements. On each card, he listed elements, their atomic mass, and properties. He did different arrangements of these cards to look for any patterns. A major breakthrough came when he arranged these elements in order of increasing atomic mass. He examined his arrangement of cards and he was looking for elements with chemical properties similar to those of sodium. He noticed something interesting that 8 elements to the left and to the right of sodium in his list were elements with chemical and physical properties identical to those of sodium. 8 element to the right was potassium and 8 element to the left was lithium. With the elements arranged in the order of increasing atomic mass, Mendeleev observed that their properties repeat in a regular way. All lithium, sodium, and potassium, they are silver colored metal. They are too reactive to exist in elemental form in the nature, and they all are good conductor of electricity. All these 3 elements, sodium, lithium, and potassium, they react with oxygen to form oxides like lithium oxide, sodium oxide, and potassium oxide that have similar chemical composition. All these 3 elements react vigorously with water in releasing flammable hydrogen gas and form hydroxides. And again, all three have same formula composition. Mendeleev observed the same pattern of 8 for other elements in his uniquely arranged list. There seemed to be something magical about number 8. And when he arranged his card to stack all elements having similar chemical properties in one column, he got 8 columns. He observed that elements that are 8 elements apart by mass, they react in a similar manner. And this phenomenon is called chemical periodicity or chemical behavior. Sometimes it is called law of octaves because the chemical periodicity repeats after every 8 element. Based on this observation, Mendeleev proposed a law that properties of elements recur in regular cycles when the elements are arranged in the order of increasing atomic mass. Mendeleev's periodic table was not perfect. Although it was very successful, but it has some defects in it. For instance, Mendeleev's periodic table was not clear about the position of isotopes. Isotopes of same element have same atomic number but different mass number. So the isotopes of the same element had to be put in a different position in the Mendeleev's periodic table as the table was based on increasing atomic mass. There were some other defects beside that the table was not clear about the position of isotopes. All those defects got resolved by modern periodic table that is arranged in the order of increasing atomic number. So all the defects of Mendeleev's periodic table got resolved by modern periodic table, and this table is arranged in the order of increasing atomic number. The modern periodic table shows atomic number, it shows atomic mass, it also conveys subatomic structure and chemical properties of elements. On this slide, I have differences between Mendeleev's periodic table and modern periodic table. Mendeleev periodic table is arranged in the order of increasing atomic mass, whereas modern periodic table is arranged in the order of increasing atomic number. Mendeleev periodic table has 6 vertical columns called groups and 12 horizontal rows called periods. Modern periodic table has 18 vertical columns called groups and 7 horizontal rows called periods. Mendeleev periodic table sometimes have elements with dissimilar properties in the same group, whereas modern periodic table have elements with similar properties in the same group. Mendeleev's periodic table doesn't support the existence of isotopes, and modern periodic table supports this fact as classification is based upon the atomic number. Let's take a brief tour of modern periodic table. The periodic table have vertical columns and horizontal rows. The vertical columns are called groups and horizontal rows are called periods. Both groups and periods are numbered. There are 7 periods from 1 through 7, and there are 18 groups in the periodic table. The groups can be numbered in a couple of different ways. They can be numbered either with Roman numerals or they can be numbered as Arabic numbers like 1, 2, 3, 4, 5 up to 18. When the groups are numbered with Roman numerals, each numeral is followed by either A or B, like we have 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, and then here we have B family. Large blocks of colors in the table indicate that the periodic table separates elements into 3 broad classes. The violet groups, we have 2 columns here for violet and 6 columns here, so altogether 8. So violet groups are called either representative or main group elements. 10 groups that is between A group are known as transition metals. Numbering in transition metals starts with 3B to 8B, and there are 3 columns assigned to 8B. And then at the end, we have 1B and 2B. There are historical reasons for this strange numbering for this B family. The elements in the upper pale green row at the bottom of the periodic table are called lanthanide series, and the elements at the lower pale green row are called actinide series. Periodic table also includes useful information about phases of matter. There are 11 elements exist in gas phase in their standard state. All these 11 you can see in the red color. These are all gases. 2 elements are liquid in their standard state, bromine and mercury. All other elements are solid in their standard state. Of the 8 representative elements, 5 groups have commonly used names. Group 1A and Group 2A are called alkali and alkaline earth metal. When metals of this group 1A and 2A are placed in water, they react with it and make water alkaline or basic. That is why they are called alkali and alkaline earth metal. Group 6A elements are called chalcogens. The name came from Greek word chalco for copper and genes for born. Most of the copper containing minerals contain oxygen and sulfur. That is why this group is named as chalcogens. Group 7 elements are called halogens. Halo is Greek name for salt, and many salts have halogens or these elements in it. That's why these elements are named as halogens. Group 8A elements are called either noble gases or rare gases as they are found in the trace amounts in the atmosphere. Elements in the periodic table can also divide it into metals, nonmetals, and metalloids. You can identify whether an element is metal, nonmetal, or metalloid by its position in the periodic table. The left side of the periodic table or all these 10 colored elements in the periodic table are metals. Blue colored elements along with this violet, they are nonmetals. In between nonmetals and metals, there are metalloids. This red stair step line that starts at the boron separates the metals from nonmetals. The elements bordering this line except aluminum and polonium, they are all metalloids. You might be wondering why we have hydrogen in nonmetal included in group 1A with alkali metals. To answer this, we will wait until the next chapter. And what you need to remember here is even though hydrogen is in group 1A, but it is not an alkali metal or it is not a metal at all. Out of 118 elements, 7 elements are metalloids, 17 are nonmetals, including these noble gases, and remaining elements are metals. Let's look at some adjustments in the law of octaves or Mendeleev's law. Law of octaves applies satisfactory when we are dealing with representative or main group elements. The chemical properties of these elements repeat after every 8 element, and this part of the periodic table contains 8 columns, so it works well in this area. But this law needs some modification if we include the rest of the elements in the periodic table. So for instance, introduction of transition metal into the periodic table causes the number of columns to swell up to 18. And in this part of the periodic table, chemical properties repeat after 18 elements instead of after every 8 elements. And when we accommodate these lanthanide and actinide series in the periodic table becomes 32 column wide. Okay, and in this region, the chemical properties repeat after every 32 elements rather than after every 18 or 8 elements. So far in the previous slides, you have seen lanthanide and actinide series as a separate block below the main part of the table. This is just a convenience to allow the table to fit better on the page. In reality, the lanthanide and actinide series should fit right into the period 6 and 7, like in this image.